Hey everybody, welcome back to the Wastewater Operations channel. I'm John Kircher, and I wanted to start a series on troubleshooting, but it's taken me a while for something to go wrong in the plant that might take more than one step to figure out something that's going on. So today I'm going to go over a problem that we see, and we're going to go over the variables and identify the cause. Now this video is going to take some time because this problem took some time to resolve. But I want this to be a series where whenever something comes up that might take some investigation, we'll go over and we'll call it a troubleshooting series. Troubleshooting is such an important part of our job because things go wrong. Figuring those out in a timely manner is part of why we're here. So I'll lay out some basic steps you can take to troubleshoot just about everything in the entire plant. As always, if you like these videos, like and subscribe down below. Here's today's problem. I know it doesn't look like much, but what I'm looking at is an aeration basin with two air legs that should be equal flow. The yellow line is air leg number 1 and the black line is air leg number 2. Now the disparity between the two is almost 30%. At this point I don't know why, and it didn't happen until we put this basin into the lead position to create a demand enough to see this high flow. As the demand goes down, the two show a little bit more congruence, but as the demand goes up like it does in the lead position, that disparity becomes really apparent. So I see that one air leg's flowing 745 SCFM and the other's only flowing about 509. It doesn't seem like a lot, but there's no reason why this should be happening. So we're going to take this basin offline and investigate and find out what's going on. So before we go outside and look at this basin, I want to go over a basic strategy about how to figure out what's going on. We're actually just going to sit down and write down all the factors we think can contribute to a given point of data. Let's say for example's sake, we were talking about the effluent TSS. The effluent TSS is just a value, it's just a number, and if we think about where it comes from a mathematical calculation of the flow and the sample. But what's the source of the flow and the sample? Well, the source of the flow is an instrument and some calculations in the PLC. The source of the sample is an actual physical sampler. Another source of the sample might be the type of sample. That could certainly show deviation. So another variable contributing to the sample is the process. So we've broken one value into two variables, and we've broken two variables into 5 variables, and we can keep going. The instrument has a calibration. The calculation should be the same, but we can at least identify if there's been any variation. The sampler itself has to be programmed. The sampler would also need to be cleaned. So there's 100 things we can break off of this one value if we're going to go and investigate. Now the process has its own, and this thing probably splits 50 more times just for that one. It's important to write this down, or at least think about it conceptually in this way, because most of the things over here tend to be a given. Now they're not a given, right? We know there's variability in all these things all the time, but for some reason we always tend to gravitate towards the process parameters. But it's important to remember all these other things. Now this is just an example for TSS. For our airflow, it's pretty simple. We have a flow measurement. That flow measurement comes from a blower. There's an instrument that's measuring that flow. There's the diffusers themselves. They could be fouled. There's the valves and actuators. There's also the process. Now, I don't have to break these down too much farther because right now I need to get started on identifying these parameters. So we called the instrumentation techs and we had them pull and verify the flow meters. Now they all came back okay, so that tells us that at least the flow read that we're getting is correct. Why is another story. After that, we took the basin offline, got it drained and cleaned out, That way we could run a pattern on the diffusers and see if there might be fouling. So we verified the pressure downstream of the actuators, and it looks like there is more pressure on the air leg that has less flow. Now that usually indicates some sort of fouling. A couple tenths of a PSI in this case can actually be really meaningful. We run the diffusers at a low flow to check the pattern, because if there was any fouling or problem, it'd be likely to see it at a low flow and it'd only be exacerbated at a higher flow. Now that's taken some time to get that basin offline, get all that stuff cleaned out, and get it ready to go in and look at that pattern. So just as we suspected, there's a good amount of fouling on portions of this air leg. Now we'll get down there and we'll get it washed off, and then we'll see what we've got for flow. So the trick to getting these diffusers to run correctly is consistency. Now that's consistency in the speed we move the pressure washer, and consistency in the distance the pressure washer is from the membrane. You can imagine if I'm looking for an even flow out of all the panels, it'd be odd if I did a lot of pressure washing on one panel and only a little bit on another. Yeah. Now that the panels show a good pattern and the pressure's come down on the air leg differential, we check the flow again. The flow's still disparate by about 25%, so we've got to go deeper. The next step is to pull off this actuator and check the piping for some obstruction causing this loss in flow. So what turns out to be the problem? Well, the indicated position on the actuator doesn't line up with the position of the flow control valve. I've set the actuator to full open, and you can see the V-ball's not open all the way. Just that 20 or 30 degree difference can totally account for the loss in flow. So an actuator that's slipped out of position is not really a common thing, but it does happen. It's important to remember to identify these things early on. It's easy to look at, it only takes a minute to verify.